Hello, geometry students. Today I'm going to show you how to use all that you've learned so far about trigonometry to tackle some more challenging problems. So let's give that a shot. So if you think you're ready for it, you just pause and try this on your own paper before you go any further, just to see how far you can get. And then press play and I'll model it for you. So in our trig equations, with our trig ratios, we have three numbers, an angle and two side lengths. And so we need to know 2 out of 3 of those measurements in order to use these equations to solve for an unknown. So if you look at the triangle on the right, you see that we only know 1 out of the 3 lengths. We don't know anything else. And so we cannot start in the triangle on the right. Also, right now, we're not sure that that even is a right triangle, and you can only do this trigonometry on a right triangle. So we have to start in the triangle on the left, which we know to be a right triangle, and in which we know 2 out of 3 pieces of information. I also want to show you that we know the angle, we want to find the opposite leg, and we know the hypotenuse. So that's where we'll start. Which trig function involves an angle, the opposite leg, and the hypotenuse? That would be sine. The sine of 44 equals opposite, W, over hypotenuse, 30. And you can solve that for 30 by multiplying both sides by 30, and then you'll get W. And you can punch that into your calculator for decimal approximation. Now that we know what W is, we can hop inside the next triangle. But before we do, you have to understand the parallel lines cut by a transversal mean alternate interior angles are congruent. That's the only reason that we know, because they're parallel lines, we know parallel lines cut by transversal, alternate interior angles are congruent. That's why we know that this is also a right triangle. And so it's kosher to do trigonometry on it. Now we found W, so now if we go inside this triangle, we know an angle, we know the adjacent side we just found, and the hypotenuse. Which trig function involves an angle, adjacent, and hypotenuse? That would be ka. The cosine of angle x equals adjacent, 20.8398, which we found in the first step, over the hypotenuse, 45. Now, this time we're missing the angle, so we have to do inverse cosine to both sides in order to do our correct inverse operation. Inverse cosine undoes cosine, out pops x, and you use your calculator to find the missing angle. And so x will be approximately 62 degrees, rounding to the nearest whole degree. Here's another kind of snazzification you can see using all of the trigonometry we've learned so far in this course. Pause and try to tackle this on your own, remembering that you can only do trigonometry on a right triangle, and then press play for the solution. So the first thing you have to realize is that you can only do trig on a right triangle. So here is a little right triangle, and here is a big right triangle. So you could do trig on either of those right triangles, but you cannot do trig on this obtuse triangle. It's simply not allowed, not at all kosher. So let's see what we can do given what we have. You can only do trig on a right triangle. So remember, you can do trig on the little blue triangle, that's a right triangle, or the big pink triangle, that's a right triangle. So how can we find what W and X given those parameters? Well, first we can find W, because we know that if we want to find W, we have an angle, opposite leg, and adjacent leg, and that's tangent. Tangent of an angle equals the opposite leg, 16, over W, the adjacent leg. W's in the denominator, so we multiply both sides by W, and then divide both sides by tangent of 70. And then we'll use our calculator to get our approximation for W. W is approximately 5.8232. All right, Next, now that we have W, we can find the whole leg of the right triangle. Because remember, we can only do trig on the right triangle. We already found W. So if we could find this whole leg, we could subtract W and we would know X. So that's our strategy. So how can we find this whole leg? We see that we have an angle, the opposite leg, and we want to find this whole adjacent leg. And so tangent is our go-to ratio. The tangent of this angle, 41, equals opposite, 16, over this whole leg. We'll just call it leg. And then we multiply both sides by the leg and divide both sides by 16 to figure out what that whole leg would be. And we get that the whole leg is approximately 18.4059. This should be approximately. And then we see that we can use the W that we previously found because this whole leg equals X plus W, and we can subtract W and we'll find X. So now you try. Pause the video and practice this on your own paper, finding both W and X. If you did not get these answers, or if you have any confusion at all, go back, rewind, and watch Snazification number 1. Pause the video and practice on your own paper and find W and X, and then press play for the solution. If you did not get these answers, or if you have any confusion at this point, pause the video, rewind, and go rewatch Snazification number 2. And I will leave you with this picture of my youngest child's fur baby, Barnaby, and wish you a lovely day.